together we can have a look at how to solve this Python sensor to the mqtt broker and then to the NodeRED, and then in the NodeRED the client and some kind of processing, and then showing on a dashboard. That was our exercise in here. So I can start showing you that one solution. We go slowly, step by step, that's how it was done. So first in here, I opened this old sensor simulator. And in that one, that was where we started this exercise with the Python simulating the sensor last week. And then you see we were in here just like importing the mqtt client, call it an mqtt. And then we have a time function also imported in here, or the time class. And then we define a broker. So that's the Mosquito organization, and then the open source broker there, the Mosquito, test mosquito.org. And then we created a client. So we have an mqtt client. It has an ID that should be different for every student. If you try at the same time, you can, at the same time, there could be just one client with the same name. And then it's in that port. And then I'm calculating like a new value 30 times, publishing those every 5 seconds. And what I publish there is I'm printing it on the screen here that I can see here that what's going on. That's why I'm printing it. And then there is the client publish. And then I'm publishing here the topic, tilt angle, and just one sensor value, which is a variable. And it's a variable with a numerical value. So it goes directly there on the payload. On the payload, so there is the topic and then the payload. And on the payload, there is the sensor value. And then that was visible there on the NodeRED. We could that print. Oh no, we just had to have a look. That had to look earlier at how it comes as a message there into the NodeRED. So this time I need to publish there a message with 2 different sensors. So I made another one, sensor simulator, 2 sensors, JSON. That's my file name here. So the file name is telling to me that, okay, I'm creating here 2 sensors and making a JSON object out of those. So it's the same program, the same, I just a little bit modified it. I modified it inside this while loop. So I have here the sensor value 1 that is changing down from 90. And then I have a sensor value 2 that is changing down from 70, a little bit faster. And then I created another variable still, called it payload. And in the Python, you don't define the type of the variable. So the Python is doing it automatically. And then when I started with as a string, it is a string. And if I start my string here, so all the next characters are inside that string. But if I write there, what is that? So if there is the first quotation mark, it marks that, okay, this is a string. And then on the next quotation mark, it will close the string. So I need to mark here that this is not the quotation mark closing the string, but it is a quotation mark inside the string. So I need to put that here, that's a backlash. Yeah, that's a backlash. So I need to put that backlash and the quotation mark, and then the and the quotation, backlash and the quotation mark. So that's my on JSON, that's the name, which is a string, D, and it's inside the quotation marks. And then I continue, I give it the value, and the value is JSON. That's why there is another. Here, and then again, this inside that JSON, I define the name. So the name is a string, which is inside the quotation mark. So quotation mark inside that string. And then that one gets a value, and the value is a string. And this is closing the first string. You see, I'm opening a string here, or starting a string here, and closing the string here. And then I append there another string, which I get from the sensor value, which is a number. And I make a string out of that one. So plus string sensor value. And then continue again with the plus sign. I indicate that I'm continuing the original string. And here starts again a string. And inside the string, there is this comma, which tells in the JSON that, okay, in the JSON, there comes a next value, name value pair. And the name is in the quotation marks. So this quotation mark is inside the string, and it's the send2. And then in the same way, I'm giving it a sensor value 2 as a value. And then now this is a complete string. And that's a payload. And then I'm publishing it. So my topic is 2 sensors. And I'm publishing the payload here. And printing out that published payload to topic 2 sensors. That should be printing in here. Let's do it. So it has published this kind of JSON there to the topic 2 sensors. And the next step is, of course, to go inside the NodeRED and have a look at what we will get there into the NodeRED. So we have here the Visual Studio Code window and the Python code, and then we go, I'll start the Python from here. It starts sending the messages out. It is sending every 5 seconds during the next 10 times 5 seconds. And then I have a browser back here, and I go to the NodeRED, and then it's connected. And I get always like 2 variables. The other one is getting smaller by 1. The other one is getting smaller by 2. So these are those 2 variables getting out of here. So of course, with this mqtt in, so that node in here I have picked up from my node list in here. And then originally, when you install the NodeRED, you should already get there the mqtt in and mqtt out. And this is the mqtt in node. Connect to an mqtt broker and subscribes to messages from the specified topic. And then I just need to specify the topic. And the topic is the topic in the message. And the topic is these 2 sensors. So that publish 2 sensors. And I need to go and I'm connected to the server. So the host test.mosquito.org on that port number and subscribe to single topic. And yeah, there is an options in here, dynamic subscription. So I can probably define here that what but I haven't tried that one. So I'm subscribing this single topic to sensors. And that's the topic. So then what comes out of there as a payload from this node in here is then what we are sending out in here. And we send out the payload, and the payload is a string. It's not a JSON object. We have defined a JSON structure inside our string. So in the NodeRED, I put here in between a JSON node. And the JSON node comes also with the original installation of the NodeRED. It's one of these nodes in here. So in here, join sequences of messages into a single message. So there's more about it in here, isn't it? So you can read from here. Join sequences of messages into single message. There are 3 modes available, automatic. So when paired with a split node, it will automatically join the messages to reverse the split that was performed. Manual joins sequences of messages into a variety of ways. So you can define those. No, sorry, I'm not in the, no, it need to be in JSON. Sorry, I was opening the wrong one. It's a JSON, this one. Converts between a JSON string and its JavaScript object presentation in either direction. And then it's that one. So converts between a JSON string and its JavaScript object presentation in either direction. So I can have as an input a JavaScript object or a JSON string. And now we have there a string input and not an object. And output. So if the input is a JSON string, it tries to pass it to a JavaScript object. If the input is a JavaScript object, it creates a JSON string. So works the both ways. So now out of this string, which is coming from the Python code, I'm creating an object. And then the object comes into my function here. My function has 1 input and 2 outputs. How is that? So I go to the function, go to the setup, and then outputs. I can increase or decrease the number of the outputs. So I can put there whatever number of the outputs. So I'll put that I have 2 outputs in there. And nothing else. That's like that. Yeah, okay, done. So now I have 2 outputs in there. So then I open it again and on the message. So I'm creating that's an JavaScript. I'm creating a variable. I'm not defining a variable type here. It is just a variable. And then I'm reading the message here. The MSG is the message which comes from the earlier node. And that's now an object. And in that's an object. So it's a message dot payload dot d dot send 1. And my variable 2 is the message dot payload dot d dot send 2. And then I'm creating an array. Again, in the JavaScript, one way of creating an array is by writing an empty array, because we don't define the variable types or anything. So to get an array, I'll just create a variable and give it like a default value, an empty array. And then Now I have defined the array, and then it has the members 0 and 1, and my array 0 is the payload, and variable 1 to string. So it is this one in here. I'm converting that back to a string. And my output on the one here, on the second, I mean, member of the array, I create there a payload, and it gets a value, and the value is a string. I'm converting this variable to as a string. And if you don't know how to do that in a JavaScript, how to get the string, so it just try out that. Convert to string. And this V3 school is rather good source of information. It's got an example codes and whatever. So I can stringify like with that one, or I can convert it to with the, so this is the second option. I mean, you can do it like this, that you can just get a string out of that one. But there is another option as well. So you can also try out the toString. And that one. So numbers to string. So that's like another way of doing the same thing. And you get a variable num, which is a number, and then you make it as a string with the num dot to string. Right, and this is a method, and then it needs to be written like this. And that one I'm using here. So back in here, I'm converting that variable to a string. And now I have a message, which is, the message is the payload and the value for the payload. And then I had two outputs, so I have two of these debugging displays in here. And what else? So I haven't changed anything. I just go to the debug and clear all and go to my Python and start it again. And it starts sending it. I'm in the NodeRED and I get the values in here. Right. And then the next step was to get this displayed on a dashboard. So to get the dashboard in the NodeRED, we needed to install an additional set of nodes. And then we installed the dashboard nodes. So it's you go in here, you manage palette, and then you try to find from here install, and you search the dashboard, and then you install the dashboard in there. And then you get all of these. And out of these, as an output, I can take a code. So as a code type widget to user interface. So two of these. And then I'll connect the first one, of course, in here, and the second one in here. Like this. And we need to define here what we are reading from here. And isn't it? It's we are reading the, like in here, we just read the message payload. And the payload has just the simple single number there. So, and group goes to control. So we put it on a home display. That's what we created last time. And then it's a codes label. I just named this simply sensor 1 and sensor 2. And it's on the group display. Label Sen2. And then I still need to label that also, that what will be on the dashboard. So this is my sensor 1 value. Just to make it that you notice that it's a different text than in here. And this is an, sorry, yeah. It's that way around. Sensor 2 value is displayed there on the NodeRED, and that's what comes on the, actually on the so I'll call this a sensor 2 meter, and that's a sensor 1 meter. And then try what happens. And we can try if we get any errors by sending from the Python. Looks promising because I get the messages and no errors. And then I need to create the dashboard display. So it was like taking the same address as your NodeRED, taking a new window. I can close those ones, take a new window right there, and UI. And then it should be in there. Only that my scale is not correct because it's from 0 to 10, and then I got the values, which are 80, 50, and so on. But it's a live display, so I can still start this one again. And it's a live display in here, so the values are changing every 5 seconds. But I need to change the scale. So that one. So minimum is 0, maximum is 100. Minimum is 0, maximum is 100. Done. Deploying. And then we are on the display in here. Right. The code was running to the end. So now we have the live display. And then if you were wondering that where are these here coming, that what is the control display and so on. So you can add their new dashboard groups and then give those a name. And for the switches, we have the control, and for the displays, we have the display. So we can put an input that we manipulate the variables in our flow, and then we can put there a display for the variables. And this time it's a display. But it's just a name. So you can name it whatever and whatever. It just creates like a new column in here. So this is the display column in here, and then there would be a control column in here if you add their control. So there was a question that how do we work with these if we have a real microcontroller and the sensor? The solution is really simple. I mean, now we are creating the sensor messages with this simulation. This is my sensor simulator, 2 sensors sending a JSON. And then I could also create there on the microcontroller a similar program, reading the real sensors and publishing to an mqtt broker. Because on the mqtt broker, it doesn't know where the message is coming from. I mean, it comes with some client ID, like we have the client ID here. I mean, that's for making the connection there into the mqtt broker. That's the broker. And then the message goes with this topic and this payload. And as a payload, there is this string. And then on the other hand, on the NodeRED, I'm just connecting to the same server, subscribing to the topic 2 sensors. And then that's it. It could be coming from anywhere. I mean, from a microcontroller or from a Raspberry Pi connected to the sensors or whatever, where you have just in the code there, you have the mqtt client, which is publishing. So we can have a look on that one on the microcontroller laboratory exercises.
I have a question about the microcontrollers and the connectivity. Are there some microcontrollers that have like a Wi-Fi connection or something like that? I'm thinking because of our group project, and we were thinking that we would have a wireless connection. So do we have to put a Raspberry Pi into it just because of the wireless connection, or can you just like?
No, that's a good question as well. So typically from the microcontrollers, if we talk about a little bit now that where the sensor values are typically coming. So if we think about a little bit like a wider scope, a real world exercises with the, not the laboratory exercises, but the real world with the Internet of Things. So for the Internet of Things, there are plenty of different kind of networks available for the communications, plenty of wireless networks available. If you are inside the building, there is an Zigbee network. If you are inside the building, there is Z-Wave network. If you are outside there in the field, in the forest or in the mountains or whatever, at the ocean, no, not at the ocean, but let's say at the in the some city area or in the fields or in the forest. So there are, for example, in Finland, there is a network covering most of the Finnish territory. There is a network with the LoRaWAN technology. So the LoRa is one of the sensor network technologies. And then there is another one is a Sigfox. Sigfox. That's also a sensor network technology for the wireless sensors. So there are microcontrollers, but with the communication capabilities. But typically, a microcontroller is then connected to a radio unit, and the radio unit microcontroller interface is done, for example, with the SPI interface, so that fast serial interface. And then the radio unit is then, we just from the microcontroller, we just give the parameters for the radio unit, and then we start the communication. In our laboratory exercises, we use the wireless LAN unit, the VLAN, Wi-Fi unit. And then in the microcontroller code, we just give the parameters for the Wi-Fi to connect to the Wi-Fi in a building. But that's for simplicity, that it's easy to work with. Every student has the Wi-Fi at home as well, and we have that in the school and so on. So everyone has the same network. So we don't need any special, let's say, procedure to connect to LoRaWAN network or Sigfox network or narrowband cellular networks or anything. So, but typically in a microcontroller, the same integrated chip, so the same silicon chip, typically hasn't got the radios integrated. But there are microcontroller boards, so those which are like 2 centimeters times 5 centimeters, that have the microcontroller and the radio unit on the same board. So that makes it rather simple to build these kind of things. And you typically don't build anything with anything like a Raspberry Pi or any, because those are consuming a lot more electric power. So those are not for the IoT sensor applications, where quite often the sensor thing is a battery powered thing, and then you can't have there something like Raspberry Pi running. All right, I think that answers. But anyway, then we can get the sensor message from a broker, and then we don't mind where it comes. We just log into the message with the topic. We are listening for that kind of topic.